is going to equal FE times distance. FE is EQ, and then multiply that by the distance. So then I get 250 times 1.67, no, I'm sorry, 1.6 times 10 minus 19 times the distance of 0.1. So it's 25 times that. And 1.66 is 150, 3.75 times 10 to the minus 18 maybe? That's the answer? 4 times 10 to the minus 18 joules of work. So I was, okay, all right. We continue now. The work done by the magnetic field, if we take the same tack and say FB times D, okay, we need to also think about, for the magnetic field, what is the orientation of the charged particle to the magnetic field to make sense? Or to make, because what is FB? Q, V, B, sine theta, and then D. And of course, if it's sine theta, what does that tell me about the velocity in the magnetic field? To maximize the force done, they have to be perpendicular. Does that make sense? So we're just going to say they're perpendicular, which would give us a sine of 1. So we're going to get Q, V, B, D. Okay, do we know Q? Yes. Do we know V? Yeah, right. They tell us that it traveled 0.1 meters in that time, right? So I'm assuming what we're saying is, what number is this? 48? Yeah. So it's traveling at a uniform velocity. So V is given by here. And since it says uniform velocity, that means constant. Does that make sense? And if it's constant, then the velocity at any time is going to equal the average velocity. So V is just going to be x over t. So we have Q x over t times B times D.